Hi, Chemistry. This is Mrs. Ellsworth. In this Unit 2, we'll be discussing many things, but the first section of it is on the scientific method. Okay, now the scientific method in your book is listed like this, and nothing is ever that simple. I do notice that they've got communicating in most of the steps, and all of them in fact, but that there's a lot of ideas on how to do this, and I'm going to use a different scientific method visual than what our book has. Here it is. And so right away, I'm thinking of something that's going on here. I'm noticing that I like cooked onions on a burger. They're nice and sweet. And these ones here, I don't like them at all. Anyway, so I made an observation. Why do cooked onions taste sweeter than raw onions? Now, that's a good question, and it's what I'm automatically thinking, but I need to do a little more research into this. Okay, so I need to do some research, and I need to observe, well, what is making it not sweet? You know, and I find out that, hey, that onions have got starch in them. So this helps me come up with a better question that will lead my hypothesis to make it easier to form a good hypothesis. So I'm going to use the question instead, does the starch in raw onions change into sugar when cooked? Okay, so that's kind of leading me into my next step, the hypothesis right here. And so I can form a hypothesis from this information here because we've got some information now. Now you notice there's a lot here. And a hypothesis just isn't a simple if-then statement. Okay, it's also talking a little bit about methods. Okay, I will test both the raw and the cooked onions for the presence of sugar and the presence of starch. Okay, and if the raw onions have only starch and the cooked onions have only sugar, this will support the hypothesis that the starch in raw onions chemically change into sugar with added heat. Okay, again, with the hypothesis, I require some methodology in there. What are you thinking? How are you going to even possibly do this? So it's got some methods. You're going to be testing for presence of sugar and starch. And it's got your thoughts on, well, what will this tell you? So from this, you'll come up with an elaborate procedure. And so you'll write down a procedure so that you can do some testing. Oh, you notice that this is very testable. A hypothesis must be testable. You can't say, well, it just happens, or some great entity came up, did this. You have to have something that is testable. Okay, and so we're going to test raw onions and cooked onions, both for starch and sugar, just like our hypothesis did. Hopefully our procedure, when we get here, our procedure was very specific because you need to have some specific things. Like even after the cooked onions are cooked, you need to have it still be the same temperature as the raw onions. You still need to have the same size pieces of onions. You need lots of things to be perfect and only changing one thing, whether it's cooked or raw. Okay, so we're going to do the testing, and from that we get that's not what we expected, is it? No, in fact, it doesn't support our hypothesis at all, but it can still be conclusive. Okay, even though it does not support the hypothesis, you could go back and figure out a different way for testing. I mean, was it the same amount? Because those are just qualitative tests that didn't give you a specific amount. I mean, if it decreased a whole lot, but yet the starch decreased a whole lot, and I mean, there's other ways of checking it out, but it is still highly conclusive that no, it didn't change. So something else causes that to happen. And of course, we relay it either in a presentation or in the form of a lab report. Oops. Okay, now I just want to remind you that we had to go back and forth on a couple of things before we could actually draw a conclusion. So this is a great scientific method visual to help us understand the scientific method. Okay, does a hypothesis graduate into theory, then into a law? If you look on the internet, there's lots of people that post even visuals of like a pyramid-shaped thing with a law up at the top and a hypothesis at the bottom. But the answer to this, does a hypothesis graduate into theory? No. Does a theory or a hypothesis graduate into a law? No. Okay, what is a hypothesis? Lots of people call it an educated guess, and I know that that makes some teachers really angry to hear that. It is an intelligent, possible way to answer a question, okay? And it must be testable, okay? You must make this a testable way and include methods in your hypothesis to help you answer the question, because you just can't say that something is going to happen because you deem it to be that way. Okay, so your hypothesis must be intelligent. So yeah, I guess why I know why they call it an educated guess, but that won't ever be an answer on any of my tests. So watch out. Anyway, so then hypothesis. Now theory. Okay, a theory is different. It's a broad generalization that explains a whole bunch of facts. Do you remember in ninth grade that you guys learned the atomic theory, and it was believed to have been small, the atoms were small little round spheres, and then it graduated and it kept on changing because Rutherford figured out that they're full of space. You know, they just kept on changing as they kept on gathering more and more information. And now the atomic theory is very, very intricate and complex. Okay, and so that generalization has been changed over time because of facts. But you know, I mean, theories always help explain why something will occur, and we're always wondering, why is this happening? How do we get, you know? So I mean, theories explain a lot of the whys, and theories can be used in your conclusion to support your hypothesis. Okay, so they're not the same thing, and I don't know how some people think that they graduate into that. Anyway. Laws. Okay, it says a natural law. It's also called a scientific law, and it's also called law. Okay, it's an explanation of how something will occur every time. Okay, it's a law that has been proved many times by gathering many experiments, like Sir Isaac Newton's laws of motion. Okay, he explained that if you're going to apply more force to it, heck, it's going to accelerate faster. Okay, it's going to take more force to push something heavier at the same rate. Okay, that's a law that has been proved, and you know what? Laws and theories can be used to help support your hypothesis. Okay, in your conclusion, you can use both of them to help support your hypothesis. Okay, now hypotheses can be written as an if-then statement. And ours is kind of written like that for our onions experiment. Okay, if we have only results of starch in the first for the raw onions, and and only sugar in the cooked onions, well, then that tells us something. So that was kind of an if-then statement. It was just worded different. Sometimes they're even started out with the belief that this will happen, you know. So those are some kind of like sentence starters to help students do better, write a better hypothesis. Okay, now theories. Can't prove them. Big Bang Theory, we cannot prove that. Okay, plate tectonics, we cannot prove that, but we've got so much information that leads us to believe it. Okay, the atomic theory, we are never going to be able to really look at it. I mean, we see some evidence. We are now getting so close to being able to see quite a bit of evidence of it, but it's just not quite, I mean, think about it. It's atomic size, and what is the size of your scope? Okay, and there's a law of gravity too. Okay, now there's one other important thing, that when you're doing an experiment, you only want to change one variable, and that is your independent variable. Okay, sometimes they're called the changed variables. In our case, we only changed raw and cooked onions. The dependent variable is what you measure. Okay, we measured sugar, and we also measured starch. So in this case, you'd have to have something different than this. You'd probably have to have some sort of bar graph. I don't know what exactly that this graph comes from here, but in this case, anytime you do any graphing of data, whether this is distance or whatever it is, anyway, that your independent variable must be at the bottom. And if there's ever time in your experiment, time is usually 99.9% of the time is on the x-axis. Okay, the variable that you use to measure, the dependent variable, that is going to be going up on the y-axis. Okay, now there are two experiments that are in our notes. Okay, here's which freezes faster, hot or cold water. What I want you to come to class with is the information about what is the dependent variable. I should put independent variable first there because that's the one that you change. The dependent one is the one that you measure. Okay, what are the controls? controls. What am I talking about? Well, in our experiment, we should have ran some controls along with it to make sure that our reagents were good. Okay, what if everything that we tested was positive? How do we know that our reagents or that our chemicals weren't bad? Okay, so I'd probably want to run water also, because those would be negative controls. They wouldn't have starch, nor would they have sugar in them. But I'd also want to test pure sugar for sugar. Test pure starch for starch, okay, to be a positive control. So there's negative and positive controls in this one here. Now constants, I know that they both start with C's and students get them mixed up. Constant, what does that mean? It means it remains the same, right? So that's what I was talking about. Do you have the same size onion pieces? Are they the same exact temperature? You know, is there the same mass? Everything that you keep identical, that is your constants. And you've got to only change one variable. All the rest must be a constant. And the variable that you change is the independent variable. Okay, controls are tests that you run along with it that you know are going to be negative or positive. Okay, what happens if you freeze water and none of them freeze? Okay, you probably got a defunct type of freezer, so that's a cause for worry, and that would make your test not work right. So their control is one that you know what your values are supposed to be. Now, the second experiment that we're going to be talking about in class, you need to be ready for it. You have to figure out the independent and the dependent variable, any constants, any controls that you would use for students at a high school becoming ill an hour after they ate the school lunch. Anyway, so read those two, come up with what your different variables are, and we'll have to discuss them in class, and I'll be checking to make sure that you are on task here. And that's the end of this first video of Unit 2.